So hello everyone, myself Krutarth Londhe from MIT Academy of Engineering. So in this video we are going to learn about bridges. So what are so we are going to see definition of bridges. Bridges are vital to transportation. They connect communities and facilitate trade. This session will explore bridge engineering, covering bridges types, components, and design. We also touch on historical milestones and current trends, as well as examine the importance of bridges in infrastructure. So, classification of bridges. So, bridges are classified by function and structure form. The golden gate is a suspension bridge, while Roman aqueducts are arc bridges. Types has unique features. So, first one is function based. So, first is highway bridge, which is you which is on the highways. Then the second one is pedestrian overpass, where pedestrian use it to pass an road or an highway. Then the second one is structure based. So first is beam bridges, then arc bridges, suspension bridges, and cable stayed bridges. So beam bridge means a simply supported beams are placed where traffic's flown on them. Then bridges are in the shape of arc, means this type of arc where a keystone is placed. If the keystone is removed, the uh, arc bridge can fall. So this is a very beautiful engineer bridge. Then next one is suspension bridges, and suspension bridge means mainly. Then the next one is cable stayed bridges. So what are the component of bridges? So first one is deck. Deck means surface where vehicles moves. In this figure, you can see this is the deck of the of or a bridge. This one. Then a girder. Girder means beam which support the deck and transport load to the piers abutment. So so you can this is the girder of our bridge, which supports the deck. The deck is supported on the uh, girder, and which transfer the load to the piers. Piers means vertical support holding the bridge span. So this is the bridge span, and the vertical supports which are holding the bridge are piers. So these are the piers of our bridge. Then abutment. Abutment is the end support uh, which connects bridge to the ground. So here we can see this is the abutment of. So this is abutment. Then the next one is foundation. Foundation is the main part of our bridge, in which the whole bridge is a whole bridge strands. So a foundation transfer load from piers abutment to the ground. Then the main component of the bridge is bearing. So bearing allows control movement between the deck and the supports. So these are the supports, means piers. And wait a minute. So this is pier, and here it is the bearing. So what is the use of bearing? Means actually what bearing does. See, if a vehicle passes through over a bridge, the there is a some movement which is caused on the bridge due to the velocity of or acceleration of the vehicle. So the uh, deck little bit moves front or back. So to give a freeway to move the deck there, so we provide here a bearing. Then economical span concept. So Economical span concept means span definition is span with minimum total cost. Then superstructure affect material costs. Then substructure impacts foundation expense. The economical span balances superstructure and substructure cost. Comparing concrete versus steel is crucial. So afflux, HFL, and score depth. So afflux means water level rise due to obstruction. So yeah, in this figure as shown, the river is flowing from upward side to downward side, and this is our bridge. So afflux means if some obstruction comes, obstruction comes between the river water, the efflux happens where means uh, the level of water increases. Then the next one is HFL. HFL means high flood level. So high flood level means the maximum height of the water in the flood condition, means in the rainy season. Then second one is score depth. Score depth is uh, uh, the main depth of the soil which happens due to erosion. So afflux is water level rise. HFL informs design and score endangers foundation. Incorrect estimation can lead to collapse. These factors are very important in design. So these three factors are very main important in our bridge design. Then loads on bridge and IRC load specification. So what types of load comes on bridge? First one is dead load, then self weight of the bridge. Then the next one is live load, uh, traffic and pedestrian load coming on the bridge. Then third one is environmental load, means wind and seismic forces. So bridge design consider dead, live, impact, wind, and seismic load. So the next one is point is failure of bridges in India. This is type of case studies. So Morbi Dam collapse in October 2020 of 143-year-old pedestrian suspension bridge over the Machuchu River collapsed just 4 days, and after reopening post renovation result in at least 141 deaths and over 180 injuries. The bridge was uh, rep- reportedly reopened without a safety clearance, and investigation pointed to crowding, and inadequate maintenance as contrib- contributing factors. So, this bridge was collapsed due to overloading of people. So, this bridge was 143 3-year-old pedestrian suspension bridge. In this incident, so the next one is Kolkata flyover, March 2016. A portion of under construction flyover in Kolkata Girish Park area collapsed, killing at least 23 people and engineering injury over 80 people. The collapse was attributed to structural failure and led to legal actions against the construction firm involved. The next one is Bihar collapse. So this Bihar bridge collapse in a span of 3 weeks. 13 bridges collapsed across various districts in Bihar, including Sarhasa and Saran. While no casualties were reported, this incident highlighted systematic issues in infrastructure maintenance and quality control. So, what is the conclusion of our this of our today's video? First is design and construction. Rough practice are crucial. Then second is inspection and maintenance. Regular checks and are essential. And third one is innovation. Explore new technologies. Thank you.